Okay, guys, so for Wednesday's quiz, you will get the trig identities, the formula sheet, so you don't have to memorize that. But what you do need to know is how to find coterminal angles and how to convert to degrees, minutes, and seconds. Those things need to be committed to memory. So the first question here asks you to find one positive and one negative coterminal. The thing we need to remember from this is that you're going to add and subtract 360 degrees from the angle itself. Angle always goes first, so it'd be negative 625. Then you would add 360. We just keep adding until we get a positive number, and then you would take negative 625 and subtract 360 to find a negative number. When you take negative 625 plus 360, you actually get negative 265 degrees. That it could be counted as your negative coterminal. Then you would just add another 360 and you would come out with 95 degrees, and then there's your positive coterminal. You could also take negative 625, subtract 360, and get that negative answer. There's a variety of answers that you could get for these questions. You just have to make sure that when you're finding coterminals, you are adding and subtracting 360 degrees from the angle. It's angle plus and angle minus. Now, in this question, when you're asked to draw angles, like let's call this one A. If I'm drawing 150 degrees, right, you're always going to start here on the initial side is the positive x-axis. Remember, this is 90, 180, 270, and 360. So 150 degrees is going to end up being over here in the second quadrant in between 90 and 180 degrees. It's positive, so we went counterclockwise or up, as we said in class. And you always make sure you draw your terminal side with an arrow, and then you draw your direction that you went. In this case, positive, so we went up. So letter B is negative 210. So if I come over here and I say, okay, this is 0, negative 360. If we go negative, it goes downwards. So this is my negative 90, negative 180, negative 270, and then negative 360. So if I go negative 210, it's going to be in between negative 180 and negative 270. So I'm going to start at the initial side here on the positive part of the x-axis, and I'm going to go down since it's negative, and I end up over here in the second quadrant. Again, you draw your arrow to show the direction that you went. Then we'll call this angle C. I have negative 425 degrees. So again, we're going to start here on our initial side. Since it's negative, I know I'm going to go downward. So this is 0, negative 360. Negative 90 is down here. Negative 180 is over here. Negative 270. So guys, if you are going negative 425, that is more than one whole circle. So you're going to go one whole circle around. That's 360 degrees. And then I have to go an additional little bit that's going to end up here in the fourth quadrant. So that's what that picture would look like. As you see, it goes around the quadrants. It's all four of them and comes back around and ends up in quadrant 4. Okay, so when we do our conversions, degrees, minutes, and seconds, I'm in decimal degrees here. So to convert to degrees, minutes, and seconds, I'm going to just do one example here. It's the same thing for, we'll say 1 and 2. Just the only difference is number 2 has a negative sign. So you're going to take your 92. That's your whole number. That's your 92 degrees. In order to find our seconds, we're going to take, or minutes, I'm sorry, we're going to take 0.472 and times that by 60. And when you multiply that in your calculator, you get 28.32. Now again, I told you guys in class, you're always going to use the whole numbers for your answer and the decimal for your calculations. So you're at 92 degrees, 28 minutes, and then I'm going to take this decimal and multiply it 0.32 times 60 to get my seconds. So 0.32 times 60, and I get 19.2. So you might be asked to round to the nearest whole number. You might be asked not to round, however the question is worded. But when we say our seconds, I'm going to say 19.2 0.2 seconds. Since it's a terminating decimal, just 0.2 ends, you can go ahead and include it. If not, I would use just the whole number. So now if we're going to go the opposite direction, we're going to convert from degrees, minutes, and seconds to decimal degrees. I'm going to do this example here. You're going to take your whole number of 85, and then you're going to add it to 46 minutes divided by 60 plus 24 seconds divided by 3,600. So guys, make sure, I know a lot of you are doing all of this stuff in your calculator and it's super easy and that sort of thing, but make sure you showing us exactly what you put in the calculator, because if you are not showing work, you are not going to receive credit. So your answer here would be 85.773 degrees. Make sure you have your degree symbol, very important. And again, show us what you are entering into your calculator so we know exactly what you're doing. All right, then we move on to these questions that talk about our trig functions and given a certain point on a terminal side, that sort of thing. Guys, the best thing to do here is to draw a picture. Number 5 says find the value of all 6 trig functions whose terminal side runs through this point. Well, where is this point? I'm going to draw my x, y. My point is at -4, so 1, 2, 3, 4, and then the square root of 3. You don't need to know exactly where that is, other than the fact that it's going to be above the x-axis. So this triangle that is formed here is in the second quadrant. Why is that important? So now you can tell the signs of your x and y, and then you can go ahead and figure out all of your trig functions. My x value is -4. My y value is the square root of 3, and I need to find my r value. R, remember, is always positive. We're going to use the little tiny formula x squared plus y squared equals r squared to figure out my r value. So my x is -4 squared plus my y is the square root of 3, and that squared equals r squared. So -4 squared is 16, plus, if I square a square root, it just cancels out, so plus 3 equals r squared. So 16 plus 3 is 19 equals r squared. So what is r? R is the square root of 19. So now that we have that information, guys, you have everything you need in order to write all the 6 trig functions. I'm going to go ahead and write right over here. X is -4, y is the square root of 3, and r is the square root of 19. So now let's write out our trig ratios. Sine of theta is y over r. Cosine of theta is x over r. Tangent of theta is y over x. And then my reciprocals. So the reciprocal of sine would be cosecant of theta. That's going to be r over y. The reciprocal of cosine is going to be secant of theta. That's going to be r over x. And then our reciprocal of tangent is cotangent, and that's going to be x over y. So now we just take our numbers, we plug them into our little ratios, and we rationalize. So I have y is the square root of 3 over the square root of 19. I'm going to rationalize that, multiply top and bottom by the square root of 19. And I get the square root of 57 over 19. So now if I take that and find the reciprocal, I'm going to flip. So this becomes the square root of 19 over the square root of 3. So I'm going to rationalize square root of 3, top and bottom. And I get the square root of 57 over 3. So now we're going to do x over r. So x is -4. -4 over the square root of 19. Again, rationalize top and bottom by the square root of 19. So I get -4 square root of 19 over 19. That would be my cosine. To find my secant, I'm going to flip that and put r over x. So that is just going to be the square root of 19 over -4. Then for tangent, it's y over x. So that is going to give me the square root of 3 over negative 4. And then if I flip that for my cotangent, that is negative 4 over the square root of 3. And again, we have to rationalize. You cannot leave radicals in the denominator. So that would give us negative 4 square root of 3 over 3. Okay, my next example, more of the same, right? You're given an x value here of negative square root of 3. You're given a y value of negative square root of 2. Let's give it ourselves a visual. Negative is going to end up in the third quadrant, somewhere over here. So that is important for us to be able to visualize, all right? My x value is negative square root of 3. My y value is a negative square root of 2, and we're going to find r. So x squared plus y squared equals r squared. So I have negative square root of 3 squared plus negative square root of 2 squared equals r squared. Remember, guys, r is always positive. So negative square root of 3 squared is just 3 plus negative square root of 2 squared is just 2 equals r squared. So r squared equals 5. R is going to be the square root of 5. So I'm going to come over here and write my x, my y, and my r, and I'm going to find all of my trig functions. So again, your x was negative square root of 3. My y is negative square root of 2, and my r value is 5. So let's write our trig functions again, our ratios. I think it's really important to write these 100 times so we memorize them, get them in our brain. Sine is y over r. Cosine theta is x over r. And tangent of theta is y over x. Our reciprocal functions, the reciprocal of sine is going to be cosecant. So cosecant is going to be r over y. The reciprocal of cosine is going to be secant. That is going to be r over x. And then our reciprocal of tangent is cotangent. And that's x over y. So let's go ahead and throw our numbers into our ratios. So y over r. My sine here is going to be negative square root of 2 over 5. If we go down the line, my cosine is going to be negative square root of 3 over 5. And then my tangent is going to be negative square root of 2 over negative square root of 3. Well, negative divided by negative is going to give me a positive. And then I'm going to rationalize with my square root of 3. A house times a house is just going to give me a bigger house. So it's a square root of 3. I'm sorry, square root of 6 over 3. Guys, that does not simplify because the square root is underneath a radical and the 3 is not. So that just stays just like it is. So now if we're going to do our reciprocal functions, if I take my sine, negative square root of 2 over 5, and I flip it, I get negative 5 over the square root of 2. And again, we're going to rationalize. So I have 5 square root of 2 over 2, and that is going to be negative. Don't forget that negative sign. We're going to flip here. I have 5 over negative square root of 3. Again, we're going to rationalize square root of 3 over the square root of 3. So it's negative 5 square roots of 3 over 3. That negative just goes out in front. And then my tangent, I'm going to flip to get my cotangent. It's going to be negative square root of 3 over negative 2, square root of 2. So again, your negatives are going to cancel, give you a positive, and then we're going to rationalize. So it's square root of 6 over 2. And again, that does not simplify because your square root of 6 is underneath the radical and the 2 is not. So now we're given a trig function and we're asked to find a different trig function. Well, if you notice here, guys, sine and cosecant are what of each other? They're reciprocals. So if the cosecant is negative square root of 5 over 2, the sine is just going to be negative 2 over the square root of 5, which we do not leave the square root of 5. So we would rationalize and come out with negative 2 square root of 5 over 5. Again, find cotangent given tangent. Well, cotangent and tangent are what of each other? They're reciprocals. So all I'm going to do is just flip. I get the square root of 3 over negative 3, and there is my answer. Don't complicate things, y'all. If that is given to you that easy, make sure you see that. All right, next one. I'm not going to do the whole thing because this becomes a little redundant, but it says find the 6 trig functions given the values here. Well, guys, how is this a little different? Well, first of all, I know it tells you that your angle is in quadrant 4, so I know it's hanging out over here. So I know that my x value is positive, and I know my y value is negative. I also know my r value is always going to be positive because r is. But they didn't give me a point here. They gave me a trig ratio. Well, when they give me sine is negative 4 over 7, they're really telling me the y value over the r value. That negative sign I know is attached to the y because r is never negative. So I know that my y value is negative 4 and my r value is 7. So we would take that information to find the x value. And then the other trig functions, which you guys have done now a bunch of times. So I have x squared plus negative 4 squared equals 7 squared. So x squared plus 16 equals 49. I'm going to subtract 16 from both sides, and I get x squared equals 33. So my x value is the square root of 33. And you would take that, guys, you would put that right here, square root of 33, and then you would find all 6 trig functions using those 3 values. Again, the answers are posted online, so you guys can check that. Because again, this is becomes a little redundant, but just practice using your trig ratios and going through the whole process. All right, we come to the next question, and it's a little bit more of the same. Find the values when. Let's talk about what they told us here. They told me that my angle is in quadrant 3. Well, why is that important? Well, let's talk about our x and our y and our r. If you're in quadrant 3, guys, what do we know about our x and y value? They are both negative. Really important that we understand that. Then they told me here that my secant is negative square root of 5. Well, what's underneath that negative square root of 5? There's a 1. You don't have to write it, but you know that it's there. And then let's think about what secant is. Secant is the reciprocal of cosine. So secant is r over x. So they're telling you that x is negative 1 and your r is the square root of 5. How do I know that negative is attached to the 1? Because r is always positive. So we're going to use x squared plus y squared equals r squared. We're going to say negative 1 squared plus y squared equals square root of 5 squared. Negative 1 squared is 1 plus y squared equals 5. I'm going to subtract 1 from both sides. So you get y squared equals 4. So your y value is 2. So now we take these values and we plug them into all 6 of the trig ratios to figure out what they all are. I'll do it real quick here. So sine of theta, remember, is y over r. Cosine theta, x over r. Tangent theta, y over x. Cosecant theta, r over y. Secant theta, r over x. And cotangent theta, x over y. So we already know our cosine and our secant because that was given to us. So our secant is going to be square root of negative 5. Let me write that. I'm getting a little messy here. So I know that my secant is the square root of negative 5. So I know my cosine is negative 1 over the square root of 5, which we're not going to leave the square root of 5, so we rationalize. So this would be negative square root of 5 over 5. I'm going to go ahead and find my sine. I look again, sine is y over r. So this is going to be negative 2 over the square root of 5. Again, we don't keep square roots. We don't leave them in a denominator. So this would be negative 2 square root of 5 over 5. Our cosecant is going to be r over y. So it's the square root of 5 over negative 2. Simple enough. And then tangent's going to be y over x. So negative 2 over negative 1 is going to give me negative 2. No, it's not when I say that. It's going to give me positive 2 because a negative divided by a negative is a positive, so it's positive 2. And then my cotangent, when I flip it, is going to be negative 1 over negative 2, which is going to give me positive 1/2. Okay, so last two, guys, and then we will talk in class tomorrow, and then I will work out the next review as well. But if you are asked to solve, and it doesn't ask you to do anything in particular, it doesn't ask you to do a specific way, you could just find x, y, and r and go with it. If the problem tells you to use the Pythagorean identities, you have to use the identities that are given to you. So in this case, they're asking us to find cosecant if we know the cosine, and our angle is in quadrant 2. Why is that important that we're in quadrant 2? Well, if I think about all students take calculus, I know that in quadrant 2, sine and its reciprocal, which would be cosecant, are positive. So that's important to remember. So I'm going to use the Pythagorean identity. Sine squared theta plus cosine squared theta equals 1. Why am I using that? Because they gave me cosine. So sine squared theta plus the cosine they gave me was negative 2/5. And I'm going to square that equals 1. So sine squared theta plus, I have 4 over 25 equals 1. I'm going to go ahead and change this to 25 over 25 just to make our math a little easier. So sine squared theta equals, I'm going to subtract 4/25 from both sides. So I have 21 over 25. And then I have to take the square root. So I get sine of theta equals plus or minus the square root of 21 over 5. And I know, ladies and gents, that my answer is going to be positive. Why do I know that this is going to be positive? Where did they tell us at the beginning that our angle was? Our angle was in the second quadrant. What do we know about the second quadrant and sine? We know that we know that sine is going to be positive. So that's wonderful. Our sine is square root of 21 over 5, but that's not what the question asked for. The question asked us for the cosecant. Well, what do we know about sine and cosecant? They are reciprocals of each other. So we just simply take our ratio here and we flip it. So our cosecant is 5 over square root of 21. Can we leave that like that? Nope. So my cosecant of theta, cosecant theta is 5 square root of 21 over 21. That's a 2. That's. Let me write it a little neater. It's 5 square root of 21 over 21. So again, one more. We're going to use Pythagorean identities. It says find the tangent. So it's usually a multi-step problem when we do this, but we are given the information that we're in quadrant 2. So again, in quadrant 2, I know that sine and its reciprocal happen to be positive. So I'm going to again use sine squared theta plus cosine squared theta equals 1. And I'm using that because they gave me cosine. So we're going to find out what sine is and use that to help us here in a second. So I have negative square root of 5 over 4 squared equals 1. So sine squared theta plus, if I distribute this to top and bottom, negative square root of 5 squared is just 5 over 4 squared is 16 equals 1. I'm going to go ahead and change this 1 to 16 over 16 to make life a little easier. So I have sine squared theta equals, I'm going to subtract 5/16 from both sides, so I have 11 over 16. I don't need sine squared, I need just plain old sine. So we're going to take the square root. So I have sine theta equals plus or minus the square root of 11 over 4. And again, guys, since we're in the second quadrant, we know that this is positive. I know that sine is positive, so sine is the square root of 11 over 4. So I know sine and I know cosine. So if you look at your Pythagorean excuse me, your Pythagorean identities and your identity sheet that you guys are going to get, you can look at your quotient identities and see, well, wait a second, how does that help me? I know that tangent of theta is sine over cosine. I know the cosine because it was given to me. I just found the sine, so I'm going to put one over the other. So I have negative square root of 5 over 4 divided by the square root of 11 over 4. Now, what do we do with that? We're going to keep negative 5 square root of 4, change, and I'm going to flip. This becomes 4 over the square root of 11. When we multiply this, guys, your 4's cancel here. So you have the negative square root of 5 over the square root of 11. We can't keep a radical in the denominator, so we're going to rationalize. And I end up with negative square root of 55 over 11 is our tangent. So all of these problems are really simple to solve. If you can remember, x squared plus y squared equals r squared. Once you know that mathematical computation, you need to remember all 6 trig ratios. X over r is cosine, y over r is sine, y over x is tangent, x over y is cotangent. All of those, you guys have got to commit those to memory.